1.7, and we're going to give this problem a try. And so this is the problem 39, and you can give it a try if you like. You can pause the video right now and try it yourself and see how you go. So we have Jeff and Carla Cole are driving separately from San Luis Obispo, California to the north shore of Lake Tahoe, a distance of 425 miles. Jeff leaves San Luis Obispo at 11 a.m. and averages 55 miles an hour on the drive. Carla leaves later at 1 p.m. but averages 65 miles per hour. Which person arrives in Lake Tahoe first? Okay, and so how are we going to go? What do you guys think? So I was thinking, well, there's kind of a formula that goes, and I was thinking about that formula, like if I traveled 1 hour, let's say I was Jeff, then I would go 55 miles, right? Because 55 miles per hour. And if I traveled 2 hours, I'd go 2 times 55, which is 110 miles. If I traveled 3 hours, right? That'd be 3 times 55. Is that 165 miles in 3 hours, right? And so that idea I was thinking of using here. And so is that you multiply the rate by the time, and that gives you the distance. And that's actually a formula that they give you in your textbook, right? And so in our case, this is just for Jeff. All right, for Jeff. We know that his rate is 55 miles an hour, and they say that's his average. What does that mean when you say your average is 55 miles an hour? Does that mean you're typically going 55 miles an hour? And no, that's not what it means. What that means is that over the whole trip, however long that took, if that trip was only 1 hour, then that meant he went 55 miles. And there might be times he was going 65 miles an hour, and there might be times he was going 42 miles an hour, but in 1 hour, he went 55 miles. So however long that trip was for him, he went, we know it's 425 miles, right? And that time that it took him would make this rate here exactly 55, if just that time. And so that's his average. So 55 times the time, which would be unknown, so I'm going to call it T for Jeff, right, is his distance, which is 425. And we're going to be able to find the time by dividing by 55. And this is going to be Jeff's time in hours. So let's see what it is. It doesn't have to be whole. And it's not. It's 85 over 11. And this is Jeff's time in hours. Now that's silly amount, and how am I going to add that on to 11 a.m., right? And so I need to convert that into, and my choice, if I want to convert this 85 over 11, I'm going to start off by converting it into a mixed number here. 7 and 8/11 hours. Oh, now it's even getting crazier, right? Okay, 7 and 8/11 hours. And so we've kind of been practicing with our time a little bit, right? And so I'm going to write this as 7 hours, and then this 8/11 hours, right, plus 8/11 hours, that's what it means, right? And so just 7 hours, and this is almost another hour. 11/11 would have been another hour. We can figure out how many minutes this is, but it's not 8 minutes. It's not 11 minutes. It's not whatever 8 divided by 11 is. It's not 72 minutes or anything like that, or 0.7 minutes. It's not that. If we want to convert it into minutes, I'm going to show you how to do that in just a second. But we can kind of see what time about he's going to get there, right? If we add 7 hours onto 11 a.m., then he's going to be getting there 7 hours on there. Am I going to have to get out my fingers? Because it goes 12 noon, right? 12 noon was 1 hour. Oh, 6 o'clock. So almost 7 o'clock, I think, is what time that he is getting there. Now, if you want to convert this into minutes, you certainly can, because you remember that 1 hour equals 60 minutes. And so that if you want to convert 8/11 hours into minutes, then you just have to multiply this by, now I want the hours to be in the denominator, 1 hour, so that the hours cancel out with each other, and the 60 minutes will be up here in the top. And then this is going to give us, so 7 hours plus, and then we'll say, no, how many minutes? So 8 divided by 11, 8 over 11, times 60 will be the minutes that it took him. And it's crazy. It's 43.6. So 44 minutes if we just round to the nearest minute. So about 44 minutes. So hopefully Carla won't be that close. And so I'm thinking that if I add that on to 11 a.m., that Jeff is going to arrive there. So 11 a.m. And if I add 7 hours and 44 minutes onto that, right, in my thought, what time is that going to be? 11 a.m. I have to count it like this. I have to go 12 a.m. That's 1 hour off, and then that gives me 6, right? So 6 p.m. and 44 minutes. I lost one of my 4s. So 6:44 p.m. Do I have it right? 11 a.m. So here we go. 12, 1, 2, 3, 4, 5, 6, 44. Okay, so that's what time Jeff gets there. So let's see about, what was her name? Carla? So her same story, right? Times time equals distance, but she instead goes 65 on average, and her time, and 4:25. So she doesn't always go 65 miles an hour. It's just her average time. Her average rate, excuse me. Her time we're about to find, 4:25 divided by 65, is again kind of crazy time, 85 over 13 hours. So again, write it as a mixed, and either as a decimal or, so 6 hours, and I'm going to write the same as I did over there, 7/13. That's not minutes, that's still hours, right? Okay, and I'm going to convert it just the same way I did here. So Carla is 6 hours plus 7/13 hours, so times 60 minutes over 1 hour. And so 6 hours, and I'm just going to go to the nearest minute plus, and then this is going to be, the hours are going to drop off, and I'm going to just go to the nearest minute. So 7 divided by 13 times 60, right? And you could do it as a fraction too. You could do the same. You can put your fraction in there, 7, and then down arrow here, and then times 60, however you want to do it. You get the same here, but that doesn't make sense for my minutes, right? So I want to push my S to D, or you could do it as mixed number if you wanted, but I'm just going to round to the nearest minute. So this is 32 minutes, because that's just a 3 in the 10th spot. So 32 minutes, and then I erased it on accident. Okay, so let's figure out what time Carla is going to get there. It said 1 p.m., right? And if we add 6 hours onto that and 32 minutes, then that means she's going to get there at 7 and 32 minutes, right? So 1 p.m. and then plus 6 hours is 7 p.m. I didn't have the tricky 12 and then 13, 1. No, it's not 13, it's 1, right? At military time, wouldn't have any problem. And so this is 7:32 p.m. So who arrives first? Jeff. And then I just asked, you know, there's some assumptions that we had to make the problem doable. And one of the assumptions that we made is they didn't stop. Right? If my average driving was 55 miles an hour, but I stopped for a 3-hour lunch, then, you know, that would add 3 hours onto my time, and still my average might have been 55 miles an hour. I don't know if you're only counting the driving time on it. And so that's what I think is there's no stops, and that it was really important that you said average in there. If you're wanting to find your average speed sometime and you're driving somewhere and you get a chance to write down what your odometer says, you know, so however many miles are in your car, let's say your car's new and you'll only have 200 miles on your car. And then when you get to your destination, that you have, you know, 210 miles, so you went 10 miles or whatever have you, and how long did it take you to get there? If you do that, you'll be really surprised that even if you went on the freeway, that your average, you know, they're saying the average here is 55 miles an hour. You'll find that you're really surprised that your average isn't as high as you would think it is. And so you guys do that, and we'll figure out what our average is. I'll do that sometime, and we'll talk about it in class. And so measure your time in minutes that it takes you to go somewhere. So and measure how far that you went. Use the odometer in your car, and we'll figure up and just kind of remember, you know, how you went, and we'll find your average rate. Okay, we'll talk to you later, my friends. Stop recording.